This video is on other applications of PivNerd. Now, so far, we realize that we can use PivNerd to determine things like P1 times V1 equals P2 times V2, et cetera, et cetera, et cetera, with all those other mathematical relationships. Well, what I'm really interested in right now is how we can determine molecular mass. Now, prior to this unit, we were doing solely gravimetric analysis, which means we're weighing stuff. And by weighing things, we can figure out the formula of a compound. So we can figure out that if we have CuSO4, we can figure out that this has 5 waters in the hydrate. Or if it's sugar, we could use gravimetric analysis through combustion analysis and figure out that the formula is C1H2O1. But we can't figure out that it's C6H12O6, so we cannot figure out the numbers and type of atoms in a single molecule of this compound through gravimetric analysis. All we're going to get is the simplest, smallest whole number ratio of moles, which is by definition an empiric formula, or empirical. Can't ever get that word right. Now, how do we get this molecular formula? Because we did use it in some questions earlier in the year, but I said we're going to get to how it's figured out. Well, here's one way of many that you can figure out. There's 2 ways of figuring it out using knowledge from gases. One of them we'll get to in a different video, and this one involves an application of PivNerd. So watch how I do this. Let's take N, for example. We'll start there with that variable. N is the number of moles, so we know that's the number of moles, right? Now, what is moles? Well, it's a given mass, which we're going to call M, over the molar mass, isn't it? Well, and since we want to abbreviate, I'm going to call this mole mass, like that. Only because I want to have to not write the whole darn thing out. Okay, moles, whatever that means. Okay? So, we can substitute that in for N. So we can go P times V equals M, that's the given mass, whatever you have, over the molar mass. So we'll put that as molar mass. Mole mass. Okay? Times R times T. Now I'm going to do some moving things around here. I'm going to basically move the molar mass to the left. So I'm going to put molar mass over here, right? And I'm going to move all the other stuff onto the other side, which will end up in the denominator. So we'll have basically M, which is the mass, times R times T. And on the bottom here, I'm going to have P and V. And what I want to focus on is at this point, if let's say we have a situation where we have a known mass of a gas, right? We know the volume of the gas, and we know the pressure and the temperature, then we can clearly figure out what the molecular mass of the compound is. Another way is by simply taking the density, because if you look very carefully, right, you see this M right here and this V right here. Well, M over V is density, so it's also another version of this formula, very simply, the density times R times T over P, some people say dirty P. I think it sounds gross, but G times R times T over P is also going to be give you the molar mass of a compound. So we're going to use this formula in one of the worksheets today to determine the molar mass of a compound. And when you get this molar mass, make sure you're clear. It's not empiric. Like this is going to give you, if the formula is, I don't know, C2H6, right? That's the formula you're going to get, because this is actually going to give you the weight of a single molecule or a mole of molecules of this substance.